Okay, very good. Hi everybody, my name is Ron Hussain. I'm one of the technical experts at Soft, and I'll be your presenter for today's webinar. The topic that we've chosen today is 4 ways to improve ASP.NET performance and scalability, and with the help of an in-memory distributed caching system, which I'll be using as an example product. NCache is our main distributed caching product. That is going to be the example product for this particular webinar. So I'll talk about NCache features, how it can help in 4 different ways to improve ASP.NET performance. So we'll be talking about ASP.NET web applications extensively in today's session. Let me quickly have a look at the attendees. Okay, very good. So we have people joined in. That's very good. For those of you who have joined this webinar and would like to participate, let me educate you towards the mode of this webinar. This is going to be a listen-only webinar where I'll be doing most of the talking, but you can always participate. If you look at the right side of your screen, there is this Go to Meeting panel. So please use the Questions and Answer tab. There is a Questions tab that you can expand and then type in as many questions as you need to. And we'll use that as a way of communication between the attendees and myself. So while I'm presenting different features of NCache, I'll keep an eye on this and post as many questions as you can so that we could keep an interactive session today. So just for the sake of verification that everything looks good, you can see my screen, you could hear me fine, just type into the Questions and Answer tab and give me a confirmation that everything looks fine. So please do that and we can pick it up from there. Very good. So right, so I've got a confirmation here. So I hope everything is fine as far as the screen sharing session is concerned. There are more people joining in, so thank you very much for joining. I think it's about time, so let's get started with the presentation. Since you can see my screen, I have the topic shown, and the topic is 4 ways to improve ASP.NET performance and scalability with an in-memory distributed caching system. And like I mentioned, that we'll be using NCache as an example product for this. My introduction, for those of you who've just joined, my name is Ron Hussain. I'm one of the technical experts at Soft. I specialize in product demonstrations, account management, technical account management. So in case you're evaluating the product, you can get in touch with me, and then I can make sure that you have a smooth start off to the successful evaluation of the product. And we can talk about different architectural approaches that you may have. So let's get started with the topic that we have in hand today: 4 ways to improve ASP.NET performance and scalability. I'll start with some introductory slides about ASP.NET platform. You could have your ASP.NET web applications in the form of old web forms or in the form of ASP.NET MVC. So these are the 2 kinds of web applications typically popular and then most commonly used. The ASP.NET platform in general is a very popular platform, and specifically for high traffic, transactional, and reference kind of data that you may have. But it's a high traffic, this platform has a capacity to handle a huge amount of request load. So applications which from a medium to high traffic use case, it has ability to scale out for that, because it scales out nicely where you can handle thousands of concurrent users, thousands of concurrent corresponding results for requests from those users. You can formulate a web form or a web garden, and you can route your requests between the available resources. And as your application load grows, you can introduce more servers into the application tier by introducing more servers in the application form. So you have more web servers, you can distribute your application load between the available number of servers. And that's what makes it so extensible, where it could it can extend itself to as many servers as you want and handle millions of requests at a given time. So this is a typical ASP.NET web form. The next slide. Typically what you do is you put a load balancer in front of your web clients, which are browser based. Those route requests through the load balancer to the resources of your application. That application can be hosted on one or two servers or even more. And on one server, you could have a web garden. And web garden is a scenario where you have one application server or web server hosting multiple instances of the same application. So if you have 3 or 4 worker processes, that's a web garden on this on that particular web server for that application. But if you take that application outside that web server and have another resource, another physical entity in the architecture, you have 2 web servers or 3 web servers, you scale out on that. That is what we categorize as web form. So if you look at the diagram, the ASP.NET Web Form layer is very scalable. It scales out horizontally, where you could add as many servers as you want, and by adding more servers, you simply increase the capacity that you can handle, the request load that you can handle from your end users. And towards the end, you have ASP.NET Session Storage, database servers, or any other backend servers. I'll come to this tier in a bit, but just to reinforce that ASP.NET platform itself is a very scalable. It allows you to handle high traffic applications, and you could have millions of requests handled by your congruent users. So where is the problem? And the agenda of this webinar, I've designed it in such a way that I'll talk about 4 different bottlenecks that you typically face within an ASP.NET application. And those are primarily the scalability bottlenecks associated with backend data sources. I'll talk in more details about these. But I'll talk about these 4 bottlenecks one by one, and then I would highlight the weakness within the architecture that you may have, and then I'll talk about solutions by presenting different features of distributed caching product of ours called NCache. So it is going to be a webinar which is going to cover 4 different features of NCache, and each feature would improve the ASP.NET performance that you have in your application, and scalability, of course. So let's highlight the scalability bottleneck. So basically, the scalability is an ability to increase the transactional load without compromising on the performance. So if you're handling about 1,000 requests per second, in future if you need to handle 1 million requests or 100,000 requests per second, you don't need to change anything in the application architecture. It should be the ability of the application within the architecture. If your load grows, we see that your applications slow down, even crash, because the resources are being maxed out. And primarily, this is on the database layer, the ASP.NET Session Storage, or the database, or any other backend data sources, because this tier is not that scalable. So let's talk about our first bottleneck on the data storage side. We have our application database. If I come back to the architecture here, we have a database server. So if it's an e-commerce application, or it could be regular day-to-day transactions, or some of product catalogs that you have in the database. So this application is going to talk to the database for every single time it needs to get some records out of it. So databases are in general slow, because they're presenting the view of all the stored data from the disk. So it's a disk-based storage. Disks are generally slow. And then databases are primarily for storage. They're not meant to handle huge transaction load. So when your application load grows, you hit a point where you cannot scale out. You don't have ability to handle more request loads. So you hit the capacity. And after that, your application performance also drops down. So you cannot add more database servers. You have limited resources, and when the physical resources of that particular database server gets maxed out, that's when you also get the performance issues. So primarily it's slow. That's the general problem. Then it does not have any ability to scale out, because you have one instance, so it's not very scalable platform. And when you have a scalability bottleneck, you always have a performance issue, in a worst possible way that you encounter. So that's our first bottleneck, and this diagram right here, you have a single source handling all your requests. Although this tier is very scalable, but you end up talking to this tier, which causes the main source of bottleneck. Now the next bottleneck within an ASP.NET application. That's our bottleneck number 2, where we have ASP.NET session storage, and that has its problems. Let's talk about these 3 different options that are presented by default by ASP.NET framework. We have in-proc session management. So if you have your ASP.NET applications storing ASP.NET session state, one option is that you keep everything inside the worker processes. For example, let's take this example. So even though if you have a web form, you keep your sessions on the web server where they're created. So everything is inside the process of your application on that particular web server. You can have a web form, but you need to have a sticky session load balancing so that wherever session gets created, all requests for that users are routed to that web server only. So that's one issue. I'll highlight that. Additionally, you cannot handle web garden scenario because within one web server, there is always one worker process which is going to have your session data. Now you have multiple worker processes. If that's a scenario, that's a preference. You cannot use in-proc sticky session bit to have a web garden. So that's a limitation on that. Secondly, I mentioned that you have a sticky session load balancing. That has a baggage of its own. Sticky session does not allow you to jump your request from one web server to another. So if a session got created on web 1, it would always be routing, the load balancer would always route all the subsequent requests to the web 1. It cannot go to web 2 because web 2 does not have the data that you need on web 1. So web 1 has the data, so request has to go to the web 1. Now that poses another problem. You could have all your sessions created on web 1, and although it routes initial request evenly, but what if the users on web 1 are still active, but web 2 and web 3 users have already logged out? Now all the current requests are belonging to the users which belong to web 1. So your other servers would not be efficiently utilized. So it's not 100% equal utilization of your resources. So your web servers may sit idle, and that's not a recommended report. The whole point of ASP.NET Web Form is that you have a very scalable platform. All your resources are utilized in an even manner, in a more efficient manner. And then there is a data loss issue. If a web server goes down, it's a power outage, or for example, it's a maintenance window. You need to take a web server offline. What would you do? You cannot do that because if your web server is taken offline, all the session data is part of that worker process which sits on that web server. So that has to go down as well. So you would end up having data loss, bad user experience, a lot of complaints on your applications for end users. So these are the problems with in-proc. Let's evaluate the second option that we have, state server. Now state server is an enhancement in comparison to in-proc, but it also has its own problems. State server is a service. It's a separate process. It could be on the same web server where your application is hosted, or it could be a separate server. So let's take an example of a separate server. Now if you have a state server, you can have equal load balancing. So it eliminates the sticky session load balancing, and it routes all your session requests to this particular server. But this is not very scalable. It's only one server, although it's fast because it's in proc. It's in memory on this memory of the service. Everything is stored, so it's not really a disk-based storage. It is memory-based, so it's comparatively fast than database. But when your application would reach a certain threshold of users, and those users would contribute a certain amount of requests per second, say 10,000 requests per second, there are chances that your ASP.NET Session Storage state server maxes out. It hits the capacity, and then there is no way that you can scale out. You don't have any ability to handle 10,000 requests per second with the same performance, if that's the capacity, and then be able to handle 20,000 requests per second when your load doubles. So that's not a possibility. So that's the issue with state server, that it's going to be not scalable. And without scalability, and at that particular point when it hits the capacity, your user request would queue up. So that would slow things down as well. And then the most fatal issue of state server is that it's only one server. So it's a single point of failure. If this server has to go down, or it has to brought down for maintenance, everything that you have you will lose entirely, because that's the single source of all the data as far as ASP.NET Session State is concerned, is residing on that particular server. So that is the source of that. So if you lose that server, you would lose everything inside your application architecture. So these are the two options. Third option is SQL Server within ASP.NET Session State storage. And I've already explained the database bottlenecks. It does not actually relate only for the application objects such as products, customers, orders. It could also be the ASP.NET Session State, and it poses the same problem where it's slow, it's not scalable, and in some cases it could also be a single point of failure if you don't have replication going on. So these are three issues within the session storage options that are available by default within Microsoft ASP.NET Session Storage. And like I said, I'll talk about solutions once we progress into the presentation. But at this point, if there are any questions, please let me know. You can always use the questions and answer tab. So this diagram, I believe there are no questions at this point, so I'll move on. So at this point, we have highlighted the application data related bottlenecks, which are associated with databases such as SQL or Oracle servers, ASP.NET Session Storage bottlenecks, in-prog state server and database related. Let's talk about two more bottlenecks, and then I'll jump right towards the solution of these and show you the actual coding examples and application examples to support that. For ASP.NET Web Forms, this is specific to ASP.NET Web Forms only. It's not something that you would see in ASP.NET MVC web applications, because that's a different architecture. So if you have ASP.NET Web Forms, you must be familiar with view state that those web forms contribute. For those of you who would like to know what view state is a client-side state management. It's HTTP. It's basically a hidden string which becomes part of your HTTP response. It travels along with the response, and it's a state of all the controls that you've used on your application. It could be your widgets, buttons, text boxes, any grids. So anything that you have on your web form, when you execute a request, those contribute a state in the form of view state, and that view state is not stored on the server side. It becomes part of your response packet as an encoded base64 string, and then it is passed on to the browser. And when you post back on that page, it comes alongside the response for the post back, and that's when it is used on the server side. So it's a thing which is needed on the server side, but it's not stored on the server side. ASP.NET default option actually takes it out of the server, makes it part of the response packet, stores it on the browser, and next time it makes it part of the response request packet, and then it brings it back on the server side to be used as a from the server standpoint to be used on the post back. Now view states are usually heavy, and I'll show you the default option once I'll demonstrate this. It could be hundreds of kilobytes per transaction, and then you could have millions of users, and those users could have millions of transactions, right? So let's take an example. You have 10,000 users, and then you have each user making 100 requests, and each request has a view state of 100 kilobyte. So 10,000 into 100 into 100 kilobyte, that's the amount of data traveling back and forth for one user or for one application at a given time. So it can have a lot of bandwidth utilization. That's the first issue with the view state. And then it can also slow down your page request and response times, because it's becoming part of the packet, and those packets are actually going to be heavier, and bigger payload would take more time to be processed. So it's a performance issue, it's a bandwidth utilization issue, and like I said, it's never really needed on the client side. It's always needed on the server side. We're still sending it back and forth along with the response and request packets. So that's our third bottleneck within an ASP.NET application, and I'll talk about a very unique way NCache specializes in how to handle view state with the help of NCache and improve performance and bandwidth utilization costs. And this diagram helps illustrates that you have the other bottlenecks, and third bottleneck is that you have a heavy payload of view state traveling back and forth between your end users and your web servers within the web form. Now, fourth bottleneck within the ASP.NET web application, and this applies for web forms as well as for MVC. Your ASP.NET page output may not change. Again, I'll give an example of e-commerce application where you have a product catalogs, and there are pages that are specific for product catalogs, and those products may not change over a period of 24 hours or for a few hours, let's say. But you're still executing those requests, and if there is a backend database involved, you always go back to the data source, construct, you get some responses against your database queries, and then construct a page. A rendered page output is actually presented to your end users. So there is a lot of execution, there's a lot of backend database calls, and then there are page rendering and page outputs being maintained and being given to your end user each time you request that page. It could be the entire page is static, or it could be portions within the dynamic page which are static. So either way, you don't want to actually execute something that you've already done, and you know ahead of time that those pages may not change, or even if they change, the frequency of that change is not that great. So in that case, it can slow your page response times when you have to have backend database involved. You're running high CPU cycles, memory, and system resources, and this can also be a cause of capacity where your application server can hit capacity because it's executing a lot of redundant calls. And we'll talk about a way of having your page outputs made available from NCache. First you store them in NCache and then make them available from NCache. So these are the four different bottlenecks that we've identified. I think it made sense. This is the diagram which talks about all of these bottlenecks in one picture. We have database bottleneck, we have session state bottleneck, we have heavy view state bottleneck, and then we have page execution bottleneck. So these are the four different issues that I'll try to tackle. I'll show you some samples, some coding as well as configuration examples to support that NCache is the right solution for you, where you could just plug in and then you can get started improving your ASP.NET performance step by step by using these four different features one by one. Any questions so far? If there are any questions, please let me know. I'll be very happy to answer those questions. You can always use the question and answer tab on the right side of your screen in the GoToMeeting panel. I'm keeping an eye on it. As a matter of fact, it's right in front of me. So please let me know if there are any questions. Okay, so assuming that everything was pretty straightforward, so like I said, now I'll talk about the solution and I'll build some background on the solution. The solution is very simple, that you use an in-memory distributed caching system such as NCache. That's our example product today. I'll talk about a distributed caching system in general. What exactly is a distributed cache? So these are some characteristics of a distributed cache. First one is that you have a cluster of multiple inexpensive cache servers, and these servers are pooled together for memory and CPU capacity. This is a logical store. It's storage for your data, session state, view state data, and that storage is presented by multiple physical resources. So it could be 2 servers, 3 servers. All these servers are joined together into a logical capacity to present the data that you've stored. And these doesn't have to be expensive servers. These could be regular web server kind of configuration boxes, and you pool them together. Second characteristic of a distributed cache is that it synchronizes cache updates across all cache servers. So one update made on one server, because now that you have a distributed system, you have multiple servers, there has to be a consistent way of applying updates. So one update applied on one server has to be visible on other servers and other clients as well. I'm using the term visible. not the replication. Replication is another concept. So by visibility, I mean that one update should be consistently applied on all caching servers and should be viewed as a consistent atomic update as far as clients are concerned, so that it is a consistent single source, which is logical source, but behind the scenes there are multiple physical servers. And the third characteristic of a distributed cache is that it should scale out linearly for transactional as well as for memory capacity. You add more servers, you should be able to have more capacity, more memory, more storage, more capacity for the application architecture. And that's the most important point for scalability benefits out of NCache, where it can scale out linearly. Unlike databases or any of the sources where you hit the capacity, it's not going to be the case with the distributed cache. And fourth one, which makes very good sense for web applications where you have session state, view state, or output caching, or even for your application data, it should replicate data for reliability. So it's fast because it's in memory. It's not disk based. Everything is within the memory, so it's extremely fast. Then we have scalability benefits. You could have as many servers added as you want. So it's linearly scalable, and on top of it, it's a very reliable store. You can take servers offline, you can bring new servers in, don't have to worry about anything. So this makes the basis of a distributed caching system such as NCache. Any questions so far? This is the deployment architecture, and I'll quickly bring you back to the slide which I showcased earlier on. This was the typical web form. Now you introduce a distributed caching layer in between your application and the backend data sources. So you have your application tier talking to a distributed cache tier. These are your web apps. For ASP.NET web applications, you don't need the web services or server app. It's just the web applications on the front end servers. Those are talking to a distributed cache tier. If it's the database, data caching, then it sits in the middle of your application and the database, where some of the data can go here, and you still have your backend database intact, where you could have that as a master source. Then it could be the sole source, the only source for session storage, for view state storage, as well as for output caching storage. Typical platform is 64-bit. There are no, all Windows environments are supported. You could have server installation here and client installation here, and then you formulate a cache and then use the client server model to connect to it, which I'll quickly demonstrate as well. I see some raised hands. If there are any questions, please let me know. And by the way, you can ask as many questions as you need to. Please go ahead with your questions. Okay, there's a question. Let's tackle that first. Okay, there's a question. How would you store something that is similar to an application global variable in NCache without being evicted from the cache? Let's say I want to store data table of rows and columns for all users and need to update the database in memory. How can that be done? Okay, that's a very simple question. So cache is a distributed to all the applications which are connected to it. We give you the API. That's one of the sections that I plan on covering. So you connect to the cache, and like I said, it's a logical cache. Behind the scenes, it could be the number of physical servers. But think of it as a source which is faster than database and more scalable than database because it's in memory and more elastic. It's a cluster, and you could have more servers. Now, you can store anything in your application. It could be your domain objects, collections, data sets, images. It could be data table as well. Now you store it in the cache, and then you have that data available for all the client applications which are connected to it. One application can add it, other applications can use it. So first of all, data is always stored in a distributed manner. So it's shared across servers. It's not inside the worker process, it's outside the worker process in a distributed tier. So it's 100% shared in a distributed manner to all the clients. Now, the next is that I want to store a database and need to update the data table in memory. How can that be done? Yes. So what you do is you get the records whenever you need to read it, and once you need to update it in the distributed cache, there is an API called cache.insert. We provide create, read, update, delete APIs. So you can create the records in the database, query from the database, create the objects, or store data table directly by using cache.add. And then when you need to read it, call cache.get. Once you need to update it, you call cache.insert. You update in the cache. And we provide synchronization features. You can update in the cache as well as in the database. So everything is built into the API layer. I hope that answers your questions. There were two questions. I hope I did justice to that. Please let me know if there are more questions around it. So moving on, let me quickly show you some performance benchmarks because that's how you would see the difference that NCache is going to bring. So I'm going to bring this right here. If I take you to the product inside NCache, there is this NCache benchmarks, and these talk about with mirrored cache, replicated. This is focused on reads then writes, but this is the topology that I was referring. So with two servers, you can expect about 50,000 reads as well as writes per second. So that's the max capacity, and if you hit the capacity, you don't have to worry about anything. You can simply add another server into the architecture, and NCache will pick it up from there. So now that we have established, and these were our own QA tests conducted with dual CPU quad-core processors with 1 kilobyte average object size. You can experiment with the same kind of tests in your labs as well, and it is expected that you may get better results because these were very nominal kind of hardware, nominal servers. So now that we've established that it's in memory, extremely fast, it's very scalable, and there are 4 different ways that we'll talk about how it's going to benefit your ASP.NET application. So let's actually get started with the creation of a distributed cache, and then I'll talk about different features one by one. And in the meantime, if there are any questions that you may have. One portion of the question was that how do I ensure that the items in the cache are available for all applications without being evicted? As long as that you have servers, everything is in memory. If you have 2 servers, you can specify the data to be removed. There could be a timeout, time-based expiration, or if the cache becomes full, you can turn on evictions. But data would stay in the cache indefinitely as long as you don't remove it explicitly. So that's something that is part of the distributed cache. It's in memory, but since there are multiple servers, if one server goes down, we have the backups available. If you don't intend to remove data yourself or don't associate a timeout, data would definitely stay indefinitely in the cache. I'll quickly take you to the demo environment. I have 2 servers right here. Demo 1 is my first server, and I also have demo 2 as the second server, which I'm using for the demonstration. So these 2 servers are going to formulate my distributed cache, and my box right here is going to be the client machine. I've already done installation of server, cache server installation on 2 boxes and client installation from where I plan to run my applications. I'll quickly create a distributed cache. I'll have to move this right here. Please bear with me. Yeah. Okay. So basically, I'm not going to spend more time on the cache configurations. I'll just give you some basic overview because the agenda of today is that we'll talk about the ASP.NET Web Application performance. But please let me know if there are any questions, any confusion. I'll be very happy to answer those for you. So I'll just create a cache. Let's say ASP.NET Cache is the name. It could be uppercase, lowercase, or mixed case. It doesn't matter. Let's say this is my name, ASP.NET Cache. Let's have the C capital as well. And I'll keep everything simple. Choose a partition replica cache topology, most popular one. Async because it's faster. This is the replication option. And here I specify the servers which are going to host my cache. I have demo 1 and demo 2 as my 2 servers which are going to host my cache. So now that I've installed NCache, I've specified the servers. I just need to choose next, and it will automatically start configuring the cache on these 2 servers. TCP port for communication. NCache is a TCP IP based cache clustering. So everything is an IP address and a port. So this is the port for communication between these two servers for this particular cache. You can have multiple caches. You could have one cache for object caching, one cache for ASP.NET sessions, one cache for web caching, for view state caching, I'm sorry. Size is based on the requirement. For example, you need your objects, view state and session data to be it could be 1 gig, 2 gig, 3 gig. So it's dependent upon the number of users and average amount of data that each user contributes inside your application. And if your cache becomes full, you can turn on evictions. For ASP.NET stateful data, I would recommend that you turn off evictions. Evictions, these are not regular evictions. These, your question was more focused on the expiration. Would data stay in the cache if I want to? So yes, that's there. These the eviction term that we use is for cache size becoming full. So you associate 1 gig of cache size. What if that cache becomes full? 1 gig is utilized. In that case, you have a way to remove some items to make room for the new items. So you turn it on for object caching, but don't turn it on for sessions, view state, and output caching. So I'll just keep everything simple, choose finish, and that's it. That has created my cache on these two servers, and in the right pane, there are all the settings which are related to this cache. I can make changes, and I can save the project, and then I can say apply configurations. Let's start this cache. Actually, let's add the client node, which is my box right here. I've already done the client installation on my box, so we're covered. And please let me know if there are any other questions in the meantime. Okay. So we have all the configurations done at this point. We have server-side cache configured, my client-side configured. You can see the client-side configurations right here. Inside the config folder, you have this client.ncconf file. And if I bring it right here, let's open it with Notepad. You have the name of the cache and the corresponding servers to connect to it. So everything is configured fine. Like I said, today's webinar is more focused on the implementation of the features, not on the server-side configurations, but we have a separate webinar in this series targeted for that. So you can even read that up or look that up on our website. There are a lot of videos available on that. So as soon as cache gets started, I'll start with ASP.NET Session caching, view state caching, and output caching, and then I'll talk about object caching. 4 different ways to improve the performance. I'll just check everything is configured fine. Statistics, these are showing the view of the cache. For example, I can see everything is configured fine. Monitor cluster, so this is going to monitor the cache as far as server side and client side caching is concerned. So let's simulate some dummy load. That is just for the sake of testing. There's a tool which comes installed with NCache. It's called stress test tool, and I'll just use it to simulate some activity on my cache cluster. There you go. So now some activity is coming. So there should be some requests, about 400 to 500 requests per second by each server. So that's the amount of request load. You can run another instance of it just to make sure that everything is configured fine, and you would see the activity increasing. There you go. About 1,000 requests per second, even more, 1,700 requests per second by each server. So that's how it scales out. So everything looks good. Let me just close these instances. And I think we're good. Any questions in the configuration so far that we've done? Okay, so first option is the ASP.NET Sessions. Assuming there are no questions, I'll move on. So these are the 4 options, just to reiterate, that I'll talk about data caching, how to use a distributed cache to store data that belongs in the database. there is an API for that. That's a code change option. But it alleviates all the database related bottlenecks without any issues. Then we have session state. So NCache as a distributed caching product can act as a session state provider. So without any code changes, your application can use NCache for session caching. And then it can also be used for view state caching. I'll talk about it, how to do that. And that's also no code change option. So without any code changes, NCache becomes your view state cache provider. It improves performance and bandwidth utilization costs. And then it can also be used for output caching. So these are the three features, number 2, 3, 4. These are no code change options, whereas feature number 1 is the code change option where you introduce the caching. And this should automatically answer the questions around how to store a data table, how to retrieve it, how to keep it in the cache for indefinite time. Let's get started with ASP.NET Session State Storage. Now, this is our most commonly used feature. You can first of all go to NCache documentation, and inside documentation you could read up about ASP.NET Sessions. By the way, all the features are listed right here. So we have all the modes that are defined here, and then it talks about how to use NCache as a custom mode where it places itself, and you can use it for session caching. And here are all the settings which are related to it. And then there are all the details that you need. And as a matter of fact, it's highly available because you can take servers offline. Now everything is in a distributed store of NCache, and you can take servers offline, add new servers, linearly scalable. Session replication is intelligently supported. Any server going down would not have any data loss or application downtime. And then we have fast recovery and dynamic clustering and WAN replication support. So these are some extended features. But just to stick to the basics, all you need to do is add these web config changes. And on our website, there is a documentation which covers this in deep details. We have ASP.NET Session Guide right here. So this talks about all the details that you need as a programmer, as a system admin to implement this feature. It would not take more than 10-15 minutes, and I'll quickly show you how this works. So this guide right here, this is what I've used, and I've constructed a sample which comes installed with NCache, and I'll be using it for demonstration of ASP.NET Session State in NCache. So first of all, this sample is part of NCache. Samples. If you go to CLR40, we have this session state sample, session state provider, and I've used this sample as is, and I've just modified the web config of it. This is exactly what you could do. This is ASP.NET Web Form sample. So if there is an application that you would like to use for session caching, all you need to do is add an assembly tag, refer the alachisaw.ncache.session-provider assembly. Once you've done that, replace your existing session state tag with NCache. So this is what you need right here. Like I mentioned that it's the custom provider. The name of the provider is session provider, and then here is the implementation of the provider. And you can specify the name to be, I've already used the ASP net cache because I had a demo yesterday as well. But you can specify any cache name. It could be a session cache that you created. I just created ASP net cache, so I'll just use it, and that's all. That's all you need to do in order to change it. Timeout is the idle timeout. If a user is idle for 30 minutes, it's in minutes. So in that case, it would automatically remove the session from the cache. If it's user keeps using its session would stay in the cache. You can set up the cookieless flag as well to true to false. You can enable exceptions so that if you need to debug something, that you can do that. ASP.NET Session locking is part of this provider. Based on Microsoft specs, you can enable locking. And this is for the scenario where you have multiple concurrent requests, such as Ajax, where one request issues a command for acquiring the session, and while it's executing, the session is not updated. updated as yet, the other request comes and then it tries to get hold of the same session. So in that case, you may get consistent results where one application's results were needed for the second request and you didn't have that. So in that case, you can lock sessions. One request can lock session and other requests wait until the lock is released. So that's how session locking works. Cache name, enable log, so write exceptions to event log. So these are all the settings that you can play around. But the idea here is that you simply need the ASP.NET cache. So I'll just go back to the server, clear the contents, and I'll show you how this works. Okay, I think we're good. Now I'll come back here and quickly launch the sample, and by changing the name of the cache, and that's it. I'll run this sample and you'll see that it would automatically spawn the application. And this web forms deployed on my machine, which is the client of ASP.NET Cache right here. It is able to use this cache for session caching. The main.aspx is the page, and there you go. By this time, one session object would be created. It's a game which it actually guesses a number between 1 and 100, and it then asks you to guess that number which was assumed by the computer. It asks you to guess that number. So let's do that. The number that you have tried is lesser than the guess. So you need to try a bigger number. It's again lesser than the guess, so right, again lesser, so let's try 100. It's greater than, so you can keep guessing. You get the idea, right? So it's presenting the number of the last guess and the previous numbers by using the ASP.NET sessions. So let's come back to the server. We should have a session object created right here, and there it is. And if I simply use a command to dump the session, there is a command where you could dump whatever you have in the cache. So I'll just use the dump cache key, and I'll say ASP.NET Cache, and I'll dump the keys which are currently part of the cache. So it says the session ID and then app1. App1 is the unique ID that I assigned to this application. You can change it, by the way. App1. It appends the session app ID that you specify with the session ID, and that's the session ID which belongs to this user. I can create another session by opening another instance. Same request, but from a different browser. So this should create another instance. So 20, 23, and you could see that it created a new session. And now if I come back here, we have one session object here and one session object here. And then if I dump the cache right here one more time, now we would see two session IDs in the cache. So you get the idea that you have a distributed store. There are two servers, so 1 and 2. Very scalable. It allows you to add more servers. You can right click and choose add node, and it would add new servers. It's very fast because it's in memory on the servers. Multiple servers contribute towards performance and request handling, and it's very reliable. You can take any server offline. So one's backup is on server 2, server 2's backup is on server 1. So there's no data loss, no application downtime. And as I mentioned, that this could be between two different data centers as well. We have multi-site session support as well. And you could have, without any code changes, you could leverage this feature as I've just explained. So this is our option number 1, without any code changes. And notice that it only took 10-15 minutes to set this up. Next, I'll quickly demonstrate the view state caching. Okay, so first I'll do what I'll do is we have the view state documentation available. You set up a section, and then you set up NCache content optimization settings. And inside you can specify the name of the cache. For example, we have ASP.NET Cache. But what I'll do is I'll set it to false first. So I would not run it without any, I'll just run it without any view state caching and see how it goes. So I'll show you the default view state behavior, and then once that is done, I'll show you the actual view state which comes into play. once I turn it on. So this is our view state caching.aspx. So it loads some records. There are a few record sets that are here. So if I view source, this is the view state right here. 2, 3, 4, 5. About 10, 12 different lines of encoded string. So this is just one page. If I navigate to the next page, there would be a new view state for that, and then you would see a different string for that. Now imagine this is one page, one user, and we're not using a lot of records here. It's not a lot of controls here. So think on the lines when you have huge amount of controls, huge amount of users, what would happen? Now I'll quickly turn on the view state and show you how this changes. I'll just save it, and then I'll show you one more time the view state. These were the view states which were consumed or which was being sent back to the browser as part of the browser. Now once we have turned on NCache view state, I'll show you the view state usage real quick. Okay, there's a question, can session of different website be stored in the same cache? Yes, of course. You could have two different applications use the same cache, and you can differentiate between the caches by using that app ID that I've shown you. Or you could have two different caches. But to answer your question, yes, same cache can have sessions for two different applications. If you want to share sessions, keep the same session IDs and same session app ID. If you don't want to share the sessions, at least keep the same different session app ID inside the application. Now NCache view state is being utilized. So I'll just say view page source and look at the view state now. That's it. That's the view state. It's just one GUID which is encrypted, and then there are some extra characters, but compare it with the view state right here. So that's the difference of view state. So what happens behind the scene is the NCache stores view state on the servers. I'll just navigate through a few pages so that a few view states get created, 4 to be precise. So NCache stores view state on the server side, and a small dummy token is what is sent back to the browser. And this is the token right here. So this makes your view state smaller. So it improves your bandwidth utilization costs, reduces that. And by improving, I mean it actually reduces the cost associated with that, improves the bandwidth utilization. And then, since the packet is smaller now, overall performance improves. And on the post back, you get the view state from the server. And I'll quickly show you the view state on the server and now that you can see that there are 3 items here and 3 items here, 6 total, 2 sessions and 4 view states. There you go. You could see a mixed value, app1 and app2, these are session IDs, whereas VS and the GUID, that is the actual view state for that. Okay, there's a question. By the way, there were 2 questions. Is there some sort of timeout for view state stored for a certain user? Yes, of course. Inside the view state, first of all, you could group view states with sessions. So if you turn this flag on, you can restrict how many view states you need per session. And after that, the older view states are automatically removed. So it keeps track of the number of view states per user. And then you could also specify the size-based threshold. Only cache the view states which are greater than certain threshold. And then on individual view states, you could also set up some expiration. Right here, expiration and duration. So these are the things that you can attach explicitly on the view states. I hope this helped. Please let me know if there are any questions. I quickly showcase the okay, there's a question. With NCache supporting session state, will it trigger the session on end event when the session timeout? If it doesn't trigger, what will be the best practice to destroy a session variable? Okay, very good. That's a very good question. I'll have to check whether a session end event is actually triggered for out of process session management. It's mostly for in proc. But NCache has its own, item remove events. So each time your session expires or you remove it by session.abandon, there is a callback that you can, hook onto. And NCache itself explicitly would send a callback. So it can be used as a replacement of session end event, but I'll confirm on that whether session end event is actually called by NCache because it's a provider. And I vaguely remember that I think the session end event was more on the in proc, utilization. If you have in proc, then it's called. For out of process, session storage, I think, it does not get fired. But even though if it gets fired or not, we have our own event that you can hook onto. So you can do some cleanup tasks, and we have a sample implementation of that available as well. Okay, very good. So let's quickly move on. The next section is the output caching, and I'll quickly show you the changes which are needed for that. And here's a sample application for that, and I'll just show you. And towards the end, I'll show you the object caching as well. So that's the fourth option. This is the third one, and then we'll move on to the fourth one. I really appreciate all the questions which were being asked. Please keep them coming if there are more questions. So this is a sample application which comes installed, and again the same approach that you add assemblies, and then you have a content caching output, and then you specify the name of the cache to be ASP.NET Cache. The way it works is that it caches the entire page output, so you don't have to re-execute the page, go back to the database, execute the request, and then render the request page output, and then present to it. So you can cache those page outputs once you have executed it, and it could be the entire page which can be which can be defined to be cached, or it could be portions within a page. So it could be a granular level where you could have a grid which is static, make it cache it output, or it could be the entire page. And there is vary by param, vary by value values, which you can actually dictate whether you want to flush that output and then actually execute the page. So if something changes, for example, you have orders of a certain customer, and that is the page that you have. If those orders are not changing, you don't have to re-execute that query. And if there is a different customer ID passed on to it, now you have a different record to be shown. So in that case, you need another execution of that request and caching of that. So this saves your execution as well as expensive cycles on the resource side. So that's our output caching. And then fourth option is our object caching within the. So we've covered session state, view state, output caching, and then I'll talk about data caching. How does it work? So this is the API that I was referring earlier on. You can get connected to this by calling the connection object, and then you can call cache.get in a key value pair. Key is a string key, value is .NET permitted object, and then you retrieve the data back as needed. As a matter of fact, I have a few buttons set up, add objects. Inside the web config, I have added the assembly references. So these are the ones that you need at the minimum, web and runtime. And the next, these are not something that you need, but those are still there, but it doesn't matter. But these are the ones you need, and then I've added some buttons on the form, and then inside the add object I'm initializing the cache, and then I'm calling cache.add, and then I'm calling cache.get to retrieve it back. So let me just launch this since I'm using the ASP.NET Cache. I should be using that. I should be actually initializing once, but since this is an old sample, so I don't want to change it at this point. So I'll launch this sample right here. There you go. So it's using the same cache. So let's clear the contents of it. Actually, just keep it. We know that there are 3 and 3, 6 items, 2 views, 2 sessions, and 4 view states. And I'm using the same cache. That also answers another question that you could use the same cache for. I'll just go ahead and I think it was on Internet Explorer. Yeah. So I'll add an object. So our customer is added in the cache. So if I come back here, now we have 4 items here, and we have about 3 items here. And if I dump cache one more time, you would see a customer David Jones added in the cache. So that's the object, and this should answer the other question as well. How do I store? And then I can actually fetch it from another where as well. I can get this. So David Jones with age 23 was retrieved. Let's update it and then get it back. And now age is 50. So that's what it's demonstrating. Total items in the cache, 7. There were 2 sessions from one browser and the other. 4 view states from one browser. That was the intended 6, and then this is the 7th object that I'm added. And then I can remove the object, and then again items in the cache are 6. I'll just start a load test, which is going to add 100 items and then start getting and retrieving and updating the items. So I just did that, and if I bring back this cache right here, it is going through a lot of activity now. You could see that about 400 requests per second are being generated, fetches per second, and then updates per second are being done on the cache as well. You could see the report view as well, and the server dashboard showing activity on the cache. So I hope this helps explain that you could have any sort of application data cached, and a distributed cache like NCache would give you full control on how to do that. Okay, there's a question which I missed. Can output caching be used with ASP.NET MVC? Yes. The only limitation for MVC, or it's not really a limitation, is around the view state. View state is only specific to web forms. MVC architecture has a different approach to it. But output caching is supported by ASP.NET Web Forms as well as for MVC. If you're interested, we can also give you a sample application around that. So this completes our session. I think we're already above 1 hour marker. I'll quickly summarize it for you. We talk about 4 different bottlenecks, and there was this diagram. We had database bottleneck, we had session state bottleneck, view state and output caching bottleneck, and then we talked about distributed caching solution, created a cache and demonstrated 4 different sample applications, and we highlighted how easy it is to use session state without any code changes, view state without any code changes, and output caching feature of NCache without any code changes. And then we talked about our data caching, and we still have our load test going on where we have a lot of customers, orders, products being added, retrieved, and updated in the cache. So cache does provide you with the more flexible, more scalable, more performant medium, and it's very reliable as well with highly available TCP/IP clustering protocol. So it would get rid of all the bottlenecks that you have in your application in regards to performance and scalability. I hope you liked the presentation. There's one other question. Is it recommended to keep the same cache? I think I've already answered that. Yes. The question is it recommended to keep the same cache for object caching and session caching, or different caches? Typically, we recommend that you have 1 cache for session and 1 cache for ASP.NET sessions view state, and then 1 cache for object caching. I'm sorry. So 2 caches, 1 for object, 1 for session caching. And primarily, this is based on the configurations. Sessions may have different cache configurations, and object cache may have different cache configurations. Other than that, if you just keep 1 cache for all the applications, all the data in one application, that's just fine. It could be between 2 different applications. So one application can have 1 cache, other application can have its own cache. But do not go beyond 3-4 different caches, because that's just not recommended. So you should not have more than 3-4 caches on given service. So yes, you can create more caches if needed. Okay, I hope you liked the presentation. Since we're already above our allocated time marker, let me quickly ask, are there any more questions? Please post into the question and answer tab if there are any. Let me just quickly review the questions that I've answered all of these. Yeah, I hope so. Okay, very good. Okay, guys. Thank you very much for your time. Let's just conclude it. Uh, it was a pleasure presenting this webinar where we were talking about different approaches. There are a few things that you can do towards the end. You can download a 60-day trial of NCache, which is a fully working product. Set up online demo or a hand-holding session with our tech support team. And then you could also send us an email at support@alachisoft.com or sales@alachisoft.com. I hope you like the product in general and the presentation as well. Please do give us your feedback, and we can take it from there. Thank you very much, everybody. Have a good day. Take care. Bye-bye.